All right, so this lesson we are going to take one last look at lines. It is the first function that we're going to look at as well. And like I said, you've been using lines for quite a while now. The different ways that you can write the equation of a line, one would be slope-intercept form, and that is y equals mx plus b. And if we're dealing with it in the function format, then this part of it would not be here. And instead we would have f of x equals mx plus b, or whatever the function name you want to give it. That is one way, but the way we're going to look at it more so today would be the point slope form, which is this particular equation, y minus y1 equals m times x minus x1, where m is the slope. And x1 and y1 are some coordinate on the graph. So here we have an equation of y equals 2x, which that is in slope-intercept form, but we're going to use point slope here in a moment. With this, if you were going to sketch the graph of it, there's a plus 0 after that. So that means it crosses the 0, or the y-axis at 0, which is right here. And then the slope is 2, which means we have to go up 2 and to the right 1 from there, and then up 2 and to the right 1 from there, and continue doing that forever and ever. And then you can also go down 2 and to the left 1, and down 2 and to the left 1. And so now we have this line. This point here is at the origin, it's 0, 0. All right, so if we choose this coordinate right here, this coordinate right here, that point is 2, 4. And if we write the equation of a line, the equation of this line using 2, 4 and using point slope form, this equation, so the 2 would go, the 4 would go there, and the 2 would go there because the 2 is the x and the 4 is y. So our equation would become y minus 4 equals 2 times x minus 2. And if we were to choose this coordinate right here, that coordinate is 4, comma 8. And if you were to write the equation of that line in point slope form, you would have y minus 8 equals 2 times x minus 4. And if we choose this coordinate right here, now we have y, because this coordinate here is a negative 1, negative 2, and that would become y plus 2 equals 2 times x plus 1. And let's pick one more coordinate. Let's go to this one here. That point is at a negative 2, negative 4. And our equation would be y plus 4 equals 2 times x plus 2. All right. Now, this yellow coordinate is how far from the blue one, as far as like, not how far like on here, but I'm talking how far do you have to go up and down and right or left? Well, either way you look at that, you're going 2 to the right and 4 up. And if you look at the orange dot, that one is 8 up and 4 to the right. The purple dot is 1 to the left and 2 down. And the red dot is 4 down and 2 to the left. Okay? Now, because of that, 2 to the right and 4 up, look at our equation for that particular point. And if you look at the orange dot, it was 4 to the right and 8 up. Look at that equation for the orange dot. That's 4 to the right and 8 up. And if you look at the purple equation, and the purple dot is 1 to the left and 2 down. And look how we have this equation written. And then with the red one, it is 2 to the left and 4 down. So let's see, 2 to the left and 4 down looks like that. So what do you notice about those equations as far as the movement is concerned? Okay. Hopefully you see that, okay, since this one was 2 to the right, with our x, because this is the x-axis, we have a 2 here. And like this one here is 4 to the right, and with our x, we have a 4. And the purple one has 1 to the left, so we have a 1. And the red one is 2 to the left, so we have a 2 there. These numbers match the movement number, right or left. Now, look at the sign of the value or in the equation that is with the x. And what you notice about the sign compared to the movement. Okay, hopefully you see that it is the opposite sign. Okay, because it's 4 to the right and we put a -4. It's 1 to the left, but we put a +1. It's 2 to the left, we put a +2. And it's 2 to the right and we put a -2. And then if you look at the y values, this one is 4 up. And here over here with the y, hey, we have a 4. With this one, there's an 8 right here. And look at this, we went 8 up. And here there's a 2, and there it is 2 down. And here there's a 4, and there it is 4 down. And is the sign the same or the opposite of what the movement is for y? Okay, it is also the opposite. So when there's movement of a coordinate left or right, you have to put it with the x. When there's movement of a coordinate up or down, you put it with the y. And in both instances, whatever the movement is, you use the opposite sign. If it's right, you put plus. If it's left, you put minus. Or no, check that. Wait a minute. If it is right, you put minus. And if it is left, you put plus. And same with the up and down. If it is up, you put a minus sign, and if it is down, you put a plus sign, and however far that you moved. Okay? That would be considered to be a line in motion. Now, one other thing you could do with these equations, actually you could do lots of different things, but the one we're going to look at would be, is if you took this equation here and you solved it for y by getting y by itself, you would have to move the 4 to the other side by adding 4. And then you get y equals 2 times x minus 2 plus 4. If you take the orange one and solve for y, you would get y equals, and we'd have to add 8 to both sides, and so then you'd get 2 times x minus 4 plus 8. And the purple one, you would subtract 2, and then you would get y equals 2 times x plus 1 minus 2. And then finally, if you take this one and subtract 4, you would get y equals 2 times x plus 2 minus 4. And now this value is a negative 4, and hey, we moved it down 4 for the red one. This value here is a negative 2, and we moved down 2. And this value is a plus 8, and we moved up 8. And this is a plus 4, and we moved up 4. So when it's away from the y value, this number stays the same. If you put it with the y value, then you write the opposite for it. Okay? Now, those properties or those concepts also would apply to something like this. Here we have a function, and it has these coordinates. So if we look at this one here, it says y equals f of x minus 2. Well, because this here is with the x, that means it is going to shift right or left. And because it is a minus 2, remember, it's the opposite action that happens. So we're going to go the opposite of a negative, which would be positive, or to the right 2 spaces for all of these coordinates. So this coordinate here is going to go 1, 2 to the right and be right there. This coordinate here is going to go 2 to the right and be right there. This coordinate is 2 to the right and is right there. Then that coordinate is 2 to the right and it is right there. And so this is the shape of it. The size of it doesn't change. How wide it is, it doesn't change. The only thing that changed is we moved all of the points 2 to the right. So what will happen with this one? Because this says plus 3 here, that means we're going to go 3 to the left. So 1, 2, 3 to the left. 1, 2, 3 to the left. 1, 2, 3 to the left. And 1, 2, 3 to the left. And there is y equals f of x plus 3. Well, now if you get something like this, y plus 3 equals f of x. Hey, there's nothing with the x here, so therefore it's shifted right or left, none. But here we have a y plus 3, which because it is here with the y, that means it is going to go down 3 units. So the blue one is 1, 2, 3 there. This point is 1, 2, 3 there. That point is 1, 2, 3 there. And this one is 1, 2, 3 there. And there's our figure for y plus 3 equals f of x. So then if we have that, y equals f of x plus 2, hey, there's nothing with the x again. And then it has a plus 2 out here, so which means that could be moved to that side by subtracting 2, so it becomes y minus 2 equals f of x, which is like the red one. Or you just leave it like this and say, well, because there's a plus 2 there, or because there's a minus 2 there, it is going up 2 spots. So take this point and go 1, 2, this point 1, 2, 2, and 2. And there's the graph of that one. Now, what happens when you get some monster like this? Here we have a couple things going on. This tells us we are moving to the right one place with all of our dots. And because there is a plus 3 there, that means it is also going up 3. So we have to take all the points and move them right 1 and up 3. So this point, right 1, 1, 2, 3. Right 1, 1, 2, 3. Right 1, 1, 2, 3. And right 1, 1, 2, 3. And so there to there to there. And you will get some things like that in your assignment today. Some of them you'll get some lines and you have to evaluate them or graph some lines or write the equation using point slope form. Other places you'll be given a figure and you might be given the figure, like you might be given this and you might be given that orange one and you have to write the equation, which could be that. I think that's how it is. Or maybe you have to, or you're given it and you have to draw the figure. Either way, it works the same. Figure out how far and which way it's moved, and if it's left and right movement, then you have to put something with your x. If it's up and down movement, then you either put something with your y, or you put it outside after the x part, like this one here. And if you're going to put it with the variable, like with the x or with the y, then remember it's the opposite of what actually happened as far as the movement is concerned. So there is your assignment for the following Tuesday, or the following Monday.